Hello everybody and welcome to Blockchain Expert. In this video, I'll be walking you through creating a decentralized voting platform. Now in this video, we'll be focusing a lot on the user experience and the front end. It's not going to look beautiful, but we're going to make it a lot more functional than in the previous videos and spend a good amount of time actually building out a front end that interacts with our smart contract using React. Don't worry if you don't know React, I will kind of teach you the basics here as we go through this video. So let me just give you a demonstration of what we're going to build, then we'll jump into the code. We'll start with the smart contract, then we'll move on and build our front end. So this is the front end here, and you can see that we have kind of two pages, one page for votes and another for creating a vote. Now, the first thing we need to do here before we can actually interact with the contract is we need to connect to MetaMask. So I'm going to press the button here to connect. This is kind of standard on most websites where you're kind of using a Web3 app here. You have to connect to MetaMask. Okay, and now that we are connected, you see we have this button, Become Member. Now, before we can actually use any of the features of this decentralized voting platform, we have to become a member of the platform. And to do this is free. However, you could implement some kind of fee or charge or something for people to kind of join this group and be able to vote. So I'm going to click on this button here to become a member. Okay, let's run our transaction here. And now you can see that we have joined. So now that we have become a member, we can actually create a vote. Now, for our vote, we're able to provide a number of options and then a description for the vote. However, we don't want to be sending that data directly to the smart contract. Instead, we're going to host that on IPFS. So what I'm going to do is go to Pinita here, which is actually what I've used to kind of host some of my vote data. And I'll click on one of them just to show you. So we have, for example, description, what is the best programming language, and then the options of Java, PHP, Python, Solidity. So I'm going to copy this IPFS / and then this aspect right here. I'm going to close that, go back here, and paste that in as my URL. Now, the number of options that we had here, I believe, was 4. So I'm going to put 4 as my options, and then I can select an end date. So for the end date, let's go with tomorrow. All right, now I can go ahead and create. So let's create this by deploying with MetaMask or sending the transaction with MetaMask, and that has been successful. Now, it usually takes a second to update, but if I go back to the votes page here, in a minute, we should see that it actually kind of posts here what the vote was, and then we can submit a vote and see the results of the vote. All right, so I've just refreshed and the vote has come in, and you can see now we have what is the best programming language, and then we can vote. So let me choose to vote, say, for Python. Let's go here. When I submit a vote, that's a transaction, so let's submit that, and it says success. And then again, we just need to wait a second, and then this will update, and we'll see that Python will have kind of 100% because that's the only person that's voted so far, and it should have a full progress bar. All right, so I've just refreshed the page. We can see Python is now at 100%. Now, what I'm going to do is change my MetaMask account and vote on something else, and I'll show you how this page updates. All right, so I'm now connected with another account. Now, for this account, I need to become a member to be able to vote, so let me do that. Okay, now I should be a member. And now we can vote for one of these other options. Let me vote for, say, Solidity. Now I'm getting an error here because I guess my membership has not yet updated. Okay, I'm going to close that. Let's refresh. Give this a second here. I'm going to have to kind of keep refreshing until it updates. And when it does, I'll be right back. All right, so now that I am a member, I can submit my vote. So let me go here and vote for Solidity. Okay, let's submit this transaction. And then again, in a second, once we refresh here, we'll see that Solidity will update. Anyways, this is a decentralized voting platform. I just want to spend some more time on the UI here in this project and really show you how to complete a fully decentralized application that has a functioning user interface and kind of some real purpose here, right? This is actually something somewhat useful. You could have some kind of organization you create. You could kind of whitelist members and allow them to vote on specific topics using a smart contract in a fully decentralized manner. I think this is quite a cool project. I look forward to you being able to build it. Now let's go ahead and hop over to Visual Studio Code and start building the smart contract. All right, so I'm here in Visual Studio Code. And as I was saying, we're going to work on the smart contract first, or the backend. So what I'm going to do is make a new directory here using mkdir. I'm going to say mkdir backend. I'm just inside of a directory, by the way. You can open up whatever you want for working on this project. And as always, all of the code will be available to download from the Blockchain Expert website. Anyways, I'm going to cd into backend. I'm going to type npm init here, npx hardhat init, and I'm going to create a new hardhat project inside of this directory. So create a JavaScript project. This will be the root, and we can kind of just go through this and install all of the dependencies. All right, so next, as always, I'm going to grab this install command and run that. And once that is done, I'll be right back, and we can start writing the contract. All right, so our dependencies are now installed. I'm inside of the backend directory, and I'm going to open up the contracts folder here and rename this to, say, voting. Let's give you the name of our contract. All right, so let's get rid of everything inside of this file once the name rechanges. Okay, so we can kind of clear all of this, change the contract name to voting, and then we can get rid of this comment. All right, so what do we need for this voting contract? Well, first of all, we need some way to understand who is a member of our kind of organization. That's kind of how I'm setting this up. We'll allow it so that anyone can become a member, but what you could do is alter this contract such that you whitelist specific addresses, or you require a fee, or you set it up in kind of whatever way you want. So we have kind of this notion of membership. After that, we have to be able to create different votes. Now, for each of these votes, we have to have kind of some URI or some URL, whatever you want to refer to it as, for the IPFS data. That IPFS data is going to be a description and the options. And then we also need to know what all of the votes are for the different options, the end time of this vote, and a few other small things that I'll get into later. Other than that, we need a way for people to, well, join, to become a member. We need a way for someone to create a vote. We need a way to vote, and we probably need some getter functions like getting information about the current vote or checking if someone has already voted. So it's not an overly complicated contract, but there is quite a few things that we need to write. So the first thing that I'm going to do here, as always, is write kind of all of my state variables and data structures. So I'm going to start by creating a variable uint, and I'm going to call this the next vote ID. Pretty straightforward what that's going to store. Next, I'm going to create a struct. I'm going to say struct vote, and we're going to store the following information. The string URI, which will be our IPFS URL. The owner of the vote, so who created the vote, essentially. We're going to have the end time, which I will store as a uint. And then we're going to have uint array, and this is going to be votes. Now, the way this will work is that the index associated with each vote in our IPFS data will kind of be here and store the number of votes. So to clarify that a bit, if we had like our options, say, Python JS, then inside of our votes array, inside of this struct, we would have like 1, 2, and that would mean 1 vote for Python, 2 votes for JS. Okay, continuing, we have to know who has already voted. So I'm going to put a mapping of an address to a Boolean telling me if a user has already voted on this specific vote. And then lastly, we need to know the number of options that we have, which I'll just specify as options so that we can make sure people don't vote on an invalid option. Next, what we need is a way to actually store all of our votes. We're going to do that based on their ID. So I'm going to say mapping, uint, and then this is going to go to a vote, and I'm going to call this our votes. Next, I'm going to have a mapping of an address to a Boolean, and this is going to tell us if someone is a member. So I'm going to say members here. So next, what I'm going to do is define 3 events that we will emit when people join as a member, create a vote, or are voting for something, like they casted a vote. Now, we won't necessarily be listening to these events, but we'll have to be querying them on the blockchain to get information about the current votes and what votes exist, and you'll kind of see how we do that when we write our front end, which is a little bit more complicated than what we've done thus far. So I'm going to say event, and then this is going to be member joined, and I'm going to say this is address, indexed, and then member. Next, I'm going to say uint and then joined at, and this will be a timestamp, right, when this member joined. Next, I'm going to have the event, which is the vote created. Now, it's kind of important that all of the information we want about a vote, or at least the information we need to kind of look up a vote, we put inside of this event. Because what we're going to be doing from our front end is kind of querying the event, right, all of the logs from this smart contract, and getting all of the vote created events. And then we're going to be taking the ones that are not expired or kind of some, filter, some criteria, and then getting more information about them and displaying that on our front end. So I'm going to say address, if we could spell address correctly, and having some trouble with that. Indexed, and then this is going to be vote, or no, not vote ID, sorry, owner. The next one is going to be vote ID, which is uint indexed vote ID. Then we're going to have the created at time. So I'm going to say uint indexed created at, and lastly, uint and then end time. Okay. Next, we are going to have an event for casting a vote. So I'm going to say voted, and then this is going to be address, indexed voter, and then we're going to have uint indexed, and then this is going to be the vote ID. We're going to have uint indexed, and then this is going to be the option that they voted for. And then lastly, uint, and then we're going to say created at. This will be the timestamp that they voted. Okay, that gives us our 3 events. All right, next what I'm going to do is just write the modifiers that we're going to need because they're fairly straightforward. So the first modifier that I want to have is member. Now for isMember, this is just going to tell us if someone is a member. We're going to have to use this for quite a few of our functions. So I'm going to say require members at message.sender. And that's just going to be a Boolean, so we can just put that directly like that. And then I'm going to say you are not a member. Then I'll put my underscore. Next, I'm going to have a modifier, and this is going to see if we are allowed to vote. So to see if we can vote, we need to know the vote ID and the option we're trying to vote for. So I'm going to say uint vote ID and the uint option. And then what we're going to do here is require a few different things. So what makes it so you are allowed to vote? Well, the vote has to exist. That means that essentially the ID of the vote needs to be less than whatever this next vote ID is, because if we haven't yet incremented the next vote ID to be equal to whatever we're passing in as the vote ID, then that means we haven't really created that vote yet. So that'll be the first thing that we check. The next thing we need to check is that you're voting for a valid option. So within the range of 0 and then whatever the number of options is. We also need to make sure that you haven't already voted and that the vote has not yet ended. All right, so let's check our first condition, which is going to be require vote ID is less than the next vote ID. Otherwise, I'm going to say vote does not exist. Okay, I am also going to require that the option that you pass is less than the votes at vote ID dot options. The reason this is strictly less than is that if we have 7 options, the available indices for votes are going to be 0 through 6, right? So that's why I'm checking that. Here I'm going to say invalid option. Okay. Next, I'm going to say require, and then this is going to be that not votes, and then at vote ID dot voted. And then we need to pass here the message dot sender. I'll explain this in a second. And I'm going to say you have already voted. So the reason this check works is that I'm looking inside of votes at vote ID. This gives me whatever vote struct that I'm kind of referencing with the vote ID. I'm looking in the voted mapping, and then I'm checking the message.sender and seeing if that's equal to true. If that's the case, then this is going to be false, right? This isn't going to work. So I'm actually checking if this is false. If that's false, this is good. Otherwise, that means you have already voted. So that's why I say that. And then lastly, we're going to say require that the block.timestamp is less than or equal to the votes vote ID dot end time, which will just store a timestamp. Okay, next I'm going to say the vote has ended. Now we can put our underscore and we have our can vote modifier. Okay, let's write our functions now. We need a function for joining, creating a vote, voting, and then a few getter functions. So the first function will be joining. So I'm going to say function join. This is going to be an external function. And then I'm going to say require that you're not already a member to join as a member. So I'm going to say members, and then at message.sender, that's what I'm going to require, that you're not already a member. I'm going to say you are already a member. Then I'm going to say members at message.sender is equal to true. And then I'm going to omit the event. So omit members joined, or member joined, and then this is going to be message.sender and block.timestamp. Okay. The next function that I'm going to write here is create vote. So for create vote, we're going to need a few things. We're going to need the URI of the IPFS data. We're going to need the end time, which is just the timestamp. And then we're going to need the number of options. Okay, now I'm going to make this an external. And I'm going to require that you are a member by using my isMember, modifier, Okay, now first thing I need to check here is that you have valid options. So we're going to kind of have like a limit of the number of options. So we're going to say you must have at least 2 options for a vote. That makes sense. But you can have at maximum 8. And then I'm going to make sure that whatever time you pass in for the end time is greater than whatever the current time is. So I'm going to say require that options is greater than or equal to 2, and that options is less than or equal to 8. And then I'm going to say number of options must be between 2 and 8. You can change this if you want, but that's what I'm going to set. And then I'm going to say require, and then the end time is greater than the block.timestamp. I'm going to say end time cannot be in past. Okay. Now, one thing to note here is that we're kind of relying on the accuracy of the user to specify the correct number of options. Now, if they specify the wrong number of options, then that just means their vote's not really going to work properly. And the reason for that is we can't validate the IPFS data that they pass here. So we ask them what the number of options are, but theoretically they could have a different number of options in their IPFS data. So if they do that, I mean, it's just they're messing up their own vote. It's not really our problem. But I just wanted to mention that it's possible the number of options they pass here is not equal to the options they have in their IPFS data. Okay, so now we need to create our vote. So I'm going to say uint vote ID is equal to the next vote ID. And then we need to set a bunch of values. So I'm going to say votes at vote ID dot URI is equal to URI. Votes again at the vote ID. We're going to use this a few times. So let me copy this and just paste this down here. Let's take these and move these forward. Okay, so votes at vote ID, and this is going to be dot owner is equal to message.sender. Next, we're going to have the end time. So we're going to say the end time is equal to the passed in end time. Next, we're going to have the options. This will be equal to the options. And then lastly, we're going to actually initialize the votes array because this is a dynamically sized array, but we actually want to create it with a fixed size so that we know we have elements in kind of positions for each of the options. So you'll see what I mean in a second, but we're going to say new uint array, and then this is going to be at the number of options. So we're actually initializing that array with a fixed size array. And that way now, whatever option you vote for will by default have a 0 in that index in this array. Hopefully that makes sense, but we need to do that to make sure we don't get an index out of bounds exception or kind of revert error, whatever you want to call it. And now that we've done that, we're going to emit our event. I'm going to say vote created. We're going to emit the message.sender. The vote ID created at is going to be the block.timestamp. Then the end time is good as it is. Okay, next we're going to say next vote ID plus plus. And that wraps up our create vote function. All right, so the next function we're going to write is the vote function. So I'm going to say function vote. We're going to say uint, and then this is going to be the vote ID that you want to vote on. And then next we're going to have the option. Now this is the index of the option you want to vote for based on the IPFS data, which again, we cannot verify. But I'm going to say function vote uint vote ID, uint option, external. We're going to put our modifiers is member as well as can vote. And for can vote, we need to pass our vote ID as well as our option. And then inside of here, I'm essentially going to cast the vote for the user because we know at this point they are able to vote. So to do that, we're going to say votes at vote ID dot, and then this is going to be votes, and this is going to be option is equal to votes vote ID dot votes, and then at option plus 1. Now, I believe we can also just do plus plus, but if we want to be explicit, we can put kind of this whole line here. So that's what I'll do. And next I will say votes at vote ID dot voted at message dot sender is equal to true, just to mark that this user has already voted. And then I will emit the voted kind of event here. So for the voter, that's going to be message dot sender. Vote ID option is fine. And then this will be block dot timestamp. Okay, let's continue here and write a few getter functions that we're going to need. So we need a way to get some information about an existing vote and to see if someone did vote for a vote. So I'm going to say function get, and then this will be vote. To get the vote, all we need is the vote ID. So you can take that here. And then this can be a public, anyone can call this view that returns. And then we're going to return string memory. We're going to return an address. We're going to return a uint array, which we'll store in memory, and then another uint value. Now, the values we're going to return here are going to be the URI, the kind of owner of this vote. Then we're going to return all of the votes, right? So an array of whatever the votes are for the different options. And then lastly, we're going to return the end time of this. So to do this, we need to use parentheses. So I'm going to return, then it's going to be votes at vote ID. Again, we can copy this, dot URI. Then we want the owner. Then we want the votes, and then we want the end time. Perfect. Let's put our semicolon. Okay, next we need our did vote function. So I'm going to say function did vote, and this is going to be address, member, and then I'm going to say uint vote ID. Again, this will be a public view that returns this time just a Boolean telling me if we did vote or not. And to do this, I'm going to return votes at vote ID dot voted at member. Okay, that's pretty much going to complete our smart contract. So let me walk through this and I'll explain kind of why I've chose some of these functions as well. All right, so we start with our next vote ID. We know why we need that. We have to keep track of vote IDs and constantly increment them, so we always have unique IDs. We have our vote struck, which we've already discussed. And then we have the votes, so just all of the vote IDs associated with each vote, as well as all of our members. So just storing which users are members using a mapping. That's the fastest way to kind of store that. If we used an array, then this array could get quite large, and it could cost a lot of gas to determine if someone was a member, which is why we don't want to do it that way. Next, we are going to go here and have our 3 events. So we have member joined, vote created, and voted. Pretty straightforward. And then we have our modifiers. Again, I don't really need to talk about those. Okay, so now we have our functions, join and create vote. So to join, you simply cannot already be a member. If you're joining, we just set it your kind of address to true inside of the members mapping, and then we emit this event. Next, create vote. To create a vote, we need to have a URI for our IPFS data, our end time, and the number of options. You must be a member to do this, and you have to pass a valid number of options as well as a valid timestamp, or end time, sorry. Now, if you pass that correctly, then what we can do is create the vote for you. So we're going to say the vote ID is equal to the next vote ID. And then for whatever that vote is inside of the mapping, we're going to set all of these fields. So the URI, the owner, the end time, the number of options, and then we're going to create a fixed size array here for the votes so that we don't have to handle kind of any edge cases, and we can just increment what is all going to be zeros starting in every single kind of option index for our votes array. Then we emit our vote created event, and we increment the next vote ID so that next time we call this function, it works correctly. Continuing, we have vote. Obviously, you can only vote if you haven't voted before on a valid vote, and if the vote is not ended. And I think there was one other thing that we did here, so let's quickly do this. And if you have a valid option. Okay, perfect. So we check all of that. We know that's going to be the case because we have our modifier. Then we go in here. We actually just vote, right? We do that by incrementing the number of votes for the option you vote for. And then we make sure that we mark that you voted and emit this event. Lastly, we have our 2 getter functions. Now, the reason I wrote these 2 getter functions is that we cannot return a mapping or kind of be able to get all of the data from a specific entry in the mapping very easily. So what I've done is written 2 getter functions that will just kind of return the data that we're looking for from a specific vote. So in one case, we want to know like all of the votes, the URI, the owner, the end time. So that's why I'm returning that here. And then lastly, I'm returning if someone voted. Now, again, same reason being here that if we look at the struct, we have a mapping of address to Boolean. Let's say I were to return this entire struct, which actually isn't even possible. But if I did return, say, this mapping element here, we wouldn't be able to kind of access this specific element inside of the mapping once it was returned. I know this seems a bit weird, but if I were to return voted rather than returning if a specific user had voted, I wouldn't be able to do anything with this voted mapping. In fact, it won't even let me just return this mapping. So I need a way for someone to be able to kind of look into that mapping and check specific values, which is what I'm doing here with did vote. Hopefully that makes a bit of sense, but the mapping type is not something that we can really return from the Solidity smart contract. So whenever you have a mapping and you want to get information from that outside of the blockchain, you need to write some kind of getter function that kind of strips that mapping and gives you the information that you're looking for, which is what I've done here. Okay. Next thing to do is to test this. So I'm not going to write this test on video just because it's very repetitive and everything I'm writing you've already seen before. You know how to do this if you followed the other projects. I will quickly run through it and I'm just going to kind of paste it in here. Now, if you want this test for yourself, then what you can do is download this from the GitHub or view it from the GitHub, or you can download the solution and just grab this test file yourself. So again, if you want this, then grab it from the Blockchain Expert website. You can drag it into your project, and then you can kind of run the test and make sure you wrote the smart contract correctly. Do whatever you'd like, but the test is available. You can download it. You don't need to take it directly from the video. Anyways, I'll quickly run through what we're testing here. So we, of course, have our before block where we're deploying the smart contract. And then what I do is I test the join functionality, creating a voting, and I believe that's actually all that I tested. So if we go to join, I'm testing if you can join. Okay, perfect. So we want to see if it emitted this event, and then I'm making sure you can't join 2 times. Next, I'm testing creating a vote. So first thing, cannot create a vote if you're not a member. Okay, fairly straightforward. Now what I'm doing here when I'm passing the end time is I'm getting the current block time and I'm adding 60 seconds to it just so that I have a valid end time. Next, cannot create vote if invalid end time. So I'm subtracting 60 seconds, meaning the time is going to be before whatever the current block time is. So I shouldn't be able to create a vote. Next, we cannot create a vote if too few options. So if we only have 1 option, it's not valid. Cannot create a vote if too many options, too many being 9. Okay, and then we can create a vote, and we can create a second vote with valid kind of parameters and making sure we're already a member and all of that kind of stuff. Next, we have voting. So cannot vote if not a member, straightforward. Cannot vote on a vote that doesn't exist. Okay, great. So I'm passing ID 2. The only IDs we would have is 0 and 1 at this point in time from the 2 votes that we created here. Next, I have that you cannot vote on an invalid option. Index 9 is not valid for vote with index 0. Okay, and then can vote, great. Cannot vote twice, and cannot vote on an expired vote. And what I've done here is use this ethers.provider.send EVM mine. This allows us to actually fast forward the block timestamp. I've fast forwarded it by 1 hour, which is 3,600 seconds, and that has allowed us to test this functionality. Great, so that is the test. Make sure you change the name here to say, what do we call this? Voting. And I will just run the test to make sure it passes for the smart contract that I just wrote. So let's type npx hard hat, and then test and make sure that this works. And we have passed all of the tests, so we are good to go. Next thing we have to do is write the deploy script. So let's go ahead and do that. The deploy script is going to be very repetitive to what we've done before. I'm just going to clean this up a bit by kind of getting rid of all this stuff that we don't need, like all of these comments. And I'm going to bring in an import that we want, which is const fs is equal to require. And then this is going to be fs/promises. I'm going to copy in a function we've written in many different projects, so I'm not going to go through this again. This is just writing our deployment info, and now let's deploy our contract. So to deploy this, we're going to say const voting is equal to await hre.ethers.get contract factory. This is for the contract named voting. We're then going to say const voting is equal to await, and then this is voting.deployed, and then we're going to say await voting.deployed here, if we can get our parentheses correct, and then we're going to say await write the deployment info, and this is for the voting contract with the name of voting.json. Okay, so that's all we need for our deployment script. Now, I'm not going to deploy this right now because we want to write our front end first. But what we need to do again is run our hard hat node, deploy this, we would get the deployment info, and then we can use that for our front end, which we're going to do later on. For now, I'm going to cd ... from my terminal. So now I'm back in this main directory. Okay, so now what I'm going to do is install or set up React. Now, the way we're going to do that is running the command npx and not hard hat, that is a habit. This is create React app. And then for the app, I'm going to call this front end like so. Now, of course, you need Node.js installed for this to work like you would need for hard hat. This is going to create a new directory for me. Once it is done, I will be right back and I'll show you kind of how we can clean this up and other things that we need to install as well. All right, so this has just finished. Now let's quickly have a look inside of the React folder here. So I'm going to go to front end. And you'll notice that we have a few folders. Now, the one folder we're interested in is src. This is where we're going to write our source code. Now, as I said, I will give you kind of a quick lesson on React, but this is not meant to be a React tutorial. So I will skim over quite a bit of information about React in general. I imagine many of you may have some experience with this. If you don't, just follow along. You'll still be able to create the project. There may just be a few things that are, maybe slightly a little bit confusing, but I'm not going to be using any advanced React features. I'm really going to be using it kind of to the very bare bones, just the basic stuff that makes it quick for us to set up a more scalable front end. So the first thing I want to do here, and you kind of just have to copy along with this, is delete a bunch of files that we don't need. So app.css, app.test.js, logo, report web vitals, and setup tests. Want to delete all of that, so let's just delete it like so. Get rid of it. In fact, we don't even need index.css. The only things we need here are app and index.js. Now let's go inside of index.js and let's remove the imports to anything that we deleted. So those are the two up at the top. And then get rid of this report web vitals function call. This is what your file should look like after kind of cleaning it up. Next, we're going to go to app.js. Let me make this a bit smaller here. And we're going to delete everything inside of this div. And we're going to get rid again of this, actually both of these imports to files we no longer have. Okay, very good. Now what we're going to do is go inside of this public folder here. And again, we're going to clean up some stuff. We actually don't need anything in here other than index.html. So I'm going to delete all of this, get rid of that, and then go inside of index.html. And again, just start deleting stuff. So I'm going to delete this icon, which is now referencing a file that doesn't exist. For the description, feel free to change this. I'm going to get rid of the references here to our logos, which again, we deleted. Going to get rid of all of these comments. And we can change the title here to be something like Decentralized Voting. Now, if you don't do this cleanup, that's fine, but I just like to kind of get rid of all of the clutter so we only have files that we actually need to focus on. Other than that, we have package.json, just storing our dependencies. Readme.md, feel free to keep this if you just want to see all of the React commands that you can use. You don't really need to have it. And now we're just going to install a few more dependencies, and then we are good to go. So what I'm going to do is cd into my front-end directory where React is installed, and I'm going to start installing a few dependencies that we need. The first one that we need is ethers. So I'm going to say npm install, and then this is going to be ethers. We need that, of course, to interact with the smart contract because it's not going to come by default because we don't have hardhat in this kind of repository here, or package, project, whatever you want to call it. Next, we are going to install Bootstrap. Now, Bootstrap is a front-end framework that allows you to kind of easily use CSS. So rather than writing any of our own CSS, we're just going to use some Bootstrap classes just to speed up the process here. So I'm going to type npm install, and then we're going to install React Bootstrap, if we can type that correctly, as well as just regular Bootstrap. Okay, so make sure you have both of those. And while we're at it here, we can install React Router DOM, which we're going to use to have kind of dynamic page routing and just have different pages just to kind of clean up our app and make it a little bit easier to navigate between different things like creating a vote and viewing the different votes. So again, React Bootstrap, and then React Router DOM. Let's install those. I'll be back when they are done. All right, so now that we have done this, there's just one more thing we need to do to install Bootstrap correctly, then we're done with the installation. So I've pulled up the Bootstrap documentation, and there is this line here, import Bootstrap dist, CSS, etc., that you need to copy. You can also just kind of copy it by pausing the video and typing it out. And we're going to paste this inside of our app component here, or inside of index. It doesn't really matter, but I'm going to go to app. And at the top of app, I'm going to paste this, and this is just going to import all of the Bootstrap styles to make sure we're not missing any of them in our project. That should be all we need to do to start using Bootstrap, and now we're kind of ready to start writing some front-end code. All right, so just as we start to get into this here, I just want to mention that what React allows us to do is essentially separate our front end out into different components. Now, each of these components have some different lifecycle methods. They have the ability to maintain their own state. You're going to see how we use that as we go through here. Again, this is going to be very, very hands-on. I'm not going to explain a ton, but you will see how to create kind of, a bare bones React application, and in this case, with different pages. So what we need to do to start is we need to set up what's known as our router. Now, the router is what allows us to, route between different pages by using like /home, /votes, /createVote, and different endpoints on the front end of our website. So to do that, we're going to go into this app component, which is automatically going to be rendered, and that's kind of already set up for us with this create React app. And we're going to return something inside of here. So rather than having this div, we're going to get rid of this, and we're going to return a router component. So we're going to say router, and then /router like so. So whenever you have a component, kind of the start of the component, the start of the tag, right, is like this, and then you end the tag just like a normal HTML tag. Now, this is a router component. However, I need to import this router component from our React Router DOM, which is something we installed that gives us access to this page routing. So I'm going to say import, and I'm going to say browser, and then this is router as router, which is the component name we're using. And then I'm going to import routes and I'm going to import root, and then this is from React router DOM. Okay, so we have our router, and anything that can be kind of routed to needs to be inside of this router. Now what we do is we define our routes. So I'm going to say routes like this, and this is where we're kind of going to write all of our different endpoints and how we kind of navigate around the website. So inside of routes, we're going to write an individual route. Okay, so the route, we can just kind of have a self-closing tag like this. And for the route, we have a name. So I'm going to say path, and then this is going to be create, and then vote. So this is the first route that we're going to have. Now, what this means is that when you go to /create vote, even though you don't need to include the slash here, whatever element I put here, and for now we're just going to put an empty element, which I'll talk about in a second, is going to be rendered on the screen. Okay, so if you go to /create vote, then it's going to render this element kind of inside of this router component. Hopefully that makes a bit of sense. So this is where we're putting our routes. Now we only need 2 routes here. We just need one for create vote and then one for votes. Okay, now that we have done this, what we want to do is we want to create those components, just kind of boilerplate them out, and I'll show you kind of how the navigation works. So let's create 2 new components inside of our SRC folder. Now, to create a component, you need to have an uppercase name for your JavaScript file or for the component itself, but in this case, we're going to put them in separate files. So for one component, this is going to be createvote.js, and for the next component, this is going to be votes.js. Now, while we're at it, we'll create another file here, which is going to be our navbar.js. I will write a navbar in a minute. Okay, so let's go to create vote. Now, for create vote, what we're going to write is const, then we're going to say create vote is equal to, and then this is going to be an arrow function. Now, what this arrow function is going to return is what's referred to as JSX, which is really just regular HTML that allows us to embed JavaScript code inside of here. We'll see how we do that in a minute, but for now, we'll just put a p tag, and we'll just say that this is the create, if we can type this correctly, vote page. Then we're going to say export, default, and then create vote, so that we can import this create vote function when we import this file. Okay, now I'm going to copy this. I'm going to go into votes. I'm going to do the same thing, except now, rather than create vote, this is going to say votes. So we need to kind of change all those references. And then this is just going to say votes page. And again, we can just go to navbar, and we can do the same thing here. So instead of create vote, we're going to say navbar, export, navbar, and actually for the navbar, we won't have a p tag. We'll just kind of put a div here for now. Okay, so we have our main components. Now let's go back to app.js and let's import these components. So I'm going to say import create vote from create votes. I probably should have just called it create vote, but that's fine. We can just leave it how it is. Next, I'm going to say import, and then this is going to be votes from ./votes. Notice you don't need to include the .js here. You can if you want, but you don't need to. And then I'm going to say import navbar from navbar. Okay, now let's just set a few things up here. So when I want to render a component, I do it by using the component name and just kind of putting it inside of a tag here. Now we can pass props to these components, and that's what these are right here. So path, this is a prop, and so is element. Now what we're going to do, though, is for the element, what we want to render when we go to the create vote page is the votes, is the create vote page, right? The create vote component. So we're going to write create vote like that, and we're going to render that component. Okay, now we're going to do the same thing here for votes, like so. So now that we've done this, we should have a navbar, and then we have our different routes. Now, the reason I put the navbar outside of the routes is so that the navbar is always going to be on the page. And in fact, what I'm going to do is make a div here. I'm going to put my routes inside of the div, and I'm going to give this a class name of container, which is a bootstrap class that just kind of spaces out some of the elements inside of this div for me. Okay, so we have our navbar, we have a container, and then inside of the container will be whatever page that we're on. Hopefully this is making a little bit of sense. I know it might be a bit confusing, but that's the basics on setting this up. All right, so now that we have this set up to actually kind of run our website and see this, what we're going to do is make sure we're inside of the front end folder, and we're going to run npm start. So if we run this command from inside of the folder, it should start our front end on localhost, and I believe it's going to be on port 3000. So it's actually automatically brought this up for me in my browser, localhost:3000. And we should see now that we are on decentralized voting. Now, what I can do is go to slash and then votes. And when I go to slash votes, it brings me to the votes page. And if I go to slash create dash vote, it brings me to the create vote page. There you go. That's really all we need. Now, one thing to note here is that once we run this server here, it's actually live updating. It's called hot reloading. And what that means is that anytime I make a change here to my components, it's automatically going to update on my front end. Now, in our case, we're probably just going to change a bunch of stuff. Then we'll go have a look at it. But in case you're curious, you can kind of work on the website while you're seeing it update in live time. So quite useful if you're actually developing an app in React. In our case, we're going to have to write kind of quite a bit of code at once to really get some results. And then we can go look at it on the front end. Okay, so now that we have our main app set up, what I want to do is create this nav bar that lets me navigate by pressing some buttons to create vote and to votes. Now, I also want this nav bar to contain those buttons you saw from my example, where we have a button that tells us if we are a member or to become a member if we're not already one, and to connect to MetaMask if we're not connected. Now, what that means is that our nav bar needs to take a few props, and those props need to tell it, okay, are you a member? Are you already connected? Etc. So I'll show you kind of how we do that in a minute, but for now, let's go to navbar. So inside of navbar, we're going to create a bootstrap navbar. Now I'm just going to write this from scratch, but I got a lot of this code from the Bootstrap website. That's why I like using Bootstrap. They have a lot of kind of pre-written components that you can just copy in. So I need to import a few things here. I'm going to import button from, not Bootstrap, this is going to be React Bootstrap. Okay. I'm going to import a container, and this is from React Bootstrap / container. I'm going to import a nav from, and this is React Bootstrap / nav. Then I'm going to import my navbar from React Bootstrap / navbar. Okay, so those are the main things that I need. All right, so I'm getting this error here saying that navbar has already been declared. That's because the name of my component is navbar, and then I'm calling this navbar. What I can do is I can just call this something like navbar underscore, and that will fix the problem for me. It's not kind of the ideal name, but that's what I'm going to use for now. Okay, so now rather than returning a div here, what I'm going to do is I'm going to return a navbar underscore. Let's spell this correctly, component. Now inside of here, or actually first, I'm going to pass a few props. So I'm going to say collapse on select. I'm going to say expand is equal to large. I'm going to say the background is dark, and the variant of this navbar is dark. Now, again, all of these options are kind of available to view from the Bootstrap website. What this is really going to do is make it so that our navbar is going to stay expanded while the screen is large. If the screen shrinks smaller, it's going to collapse, and that's going to allow us to kind of press a little button like you would see on mobile to kind of expand the navbar and see all of the different options. I'll show you what that looks like in a second. Now, for the navbar, we're going to have a container. We're going to specify this as fluid, which just means it's going to space out a little bit. And then we are going to do a few things with our navbar. So I'm going to say navbar.brand. And for our brand, I'm going to say href is equal to /, so just the empty root. And I'm going to call this voting. Now, this is what you're going to see in the top left-hand corner. It's kind of the name of our website. Next, I'm going to have a toggle control. So I'm going to say navbar.toggle. Okay, this is going to be a self-contained component. I'm going to say, actually, I don't need to specify that, so I won't write that. I'm just going to say navbar toggle. That's actually all we need. And then I'm going to have a navbar and then dot collapse. And this is not going to be a self-contained component. And that's all we need here. Now, anything inside of this navbar collapse is going to be collapsible, right? So when I press the button, it's going to collapse or uncollapse. So that's kind of why I'm putting it inside of here. Inside of here, I'm going to say nav, and I'm going to put the class name equal to, and then it's going to be me.auto. Now, this stands for margin end auto, okay? And that means it's going to kind of space us out correctly such that we're always on the left-hand side of the screen rather than the right-hand side. Now, inside of this first kind of nav container, I'm going to put my different nav links. So I'm going to say nav.link. Again, all of this, if you want to look at it in more depth, is on the Bootstrap website, but I'm going to try to explain it. For the href, we're going to have / and then this is going to be votes. and then I'm going to call this votes. Okay, so this is a link. This means when you press this button, it's going to bring you to the /votes page, and then we'll render, well, all of our votes eventually. Next, we're going to have create vote, and then we'll say here, create vote like so. And then we're going to show a button that tells us to become a member. So let's do the button now, and then we'll kind of dynamically render it later on when we want to be showing it. So for the button, I'm going to say variant is equal to success. This is going to make the button green. And then I'm going to say become member. Okay, so now we'll have a green button. So that's the first aspect. Next, we want to have a button on the right-hand side of our screen that says connect to MetaMask. So I'm going to say nav. And just by putting this other nav container here, so we have kind of this nav one and now this nav one, it's automatically going to be pushed to the right-hand side of the screen because we added this class name of margin end auto. So that's going to push this nav bar to the left, and then this, I don't want to say nav bar, but part of the nav bar to the right side of the screen to kind of space it out. So now inside of nav, I'm going to put a button, and I'm going to say connect to MetaMask, and I don't need to put anything else. The default color is blue, which is the color that I want to have. All right, so I know this is a little bit confusing here, but let's open up our kind of Chrome window, and let's refresh. And for some reason, it is not showing my nav bar. Okay, let me go to the console and see what's going wrong here, and then I'll be right back. All right, so I've just kind of dug around here and realized I made a little bit of a mistake. So I've said import navbar here with an underscore, and then I've used it here, but I've used regular navbar everywhere else. Now I've realized what's going to be easier is if I just change this to say navbar, and I change this component to just say something like navbar top. Then I export default navbar top. Now that I've done that, everything should be good here. So let's go back to our front end. And there you go. We can see that we are getting a navbar, and notice this is kind of what I was talking about. It kind of expands with this button. Now, if I make it larger, notice that it like fully expands out. And sorry, I meant it kind of collapses with this button or uncollapses. So there you go. We have our navbar. We have this stuff on the left, this stuff on the right. You know, it's arguable how good this looks, but you get the point. There you go. That is a navbar. Okay, so now that we have our navbar, what we want to do is make it so we can connect to MetaMask, become a member, and start interacting with the contract. Then we can do what I won't lie is a little bit more complicated, which is kind of creating the vote and rendering all of the different votes out. All right, so what we're going to do now is create a new file inside of SRC, and I'm going to call this contract.js. Now inside of here, we're going to say import ethers from ethers. And we're going to start writing essentially what we've done in all of the other projects where we have our contract address, the ABI, our provider, and then we're going to write some functions that allow us to kind of return that to our main React application. So we're going to say export const address is equal to, and actually we don't need to export this, so let me get rid of that. Next, we're going to have our ABI. So const ABI is equal to this. We're going to fill these in a second. Then we're going to have const provider is equal to new ethers dot providers dot, and then this is going to be web3 provider, and then window dot Ethereum is what we want. Okay, so I believe that is correct. Now we're going to write a function. I'm going to say export const connect. We do want to export this so we can access it from our other components. This is going to be an async function, and we're going to say await provider dot send, and then we're going to have eth underscore request underscore accounts, and sorry, this needs to be with a capital A, and then we're just going to pass an empty array. Okay, next we're going to say return get contract, and get contract is going to be a function that we write down here. I'm just going to say export const get contract. This again is going to be an async function. So async like so. And sorry, we need to put this after the async. And inside of here, we're going to say our const signer is equal to provider dot get signer. And then we're going to say const contract is equal to new ethers dot contract. We're going to pass our address, our ABI, and our signer. And then we're going to return an object, and this object is going to have our signer as well as our contract so that we can access both of these from our front end. Now I want to grab the address and the ABI, but before we can do that, we need to actually deploy our contract. So I'm going to stop my React server here. I'm going to cd ... cd into my backend, and I'm going to run my hard hat node and then deploy my contract and then get that information. So I'm going to say npx hard hat node to start that. While that runs, I'll split the terminal over here. And then I'm going to go cd backend again, then npx hard hat, and then this is going to be run deploy, and then, sorry, not run deploy, run ./scripts/deploy.js. Then this is going to be -- network, and then localhost. Okay, so I think that should be good. Let's run that. And we got an error here. It says voting.deployed is not a function. Okay, so let's go to our deploy script in backend and see where I made a mistake here. So scripts deploy. I think this needs to just say deploy, not deployed. And let's try to run this now. Okay. And there we go. Looks like it did actually complete. Now we should have, our voting.json file. So let's copy the ABI first of all and put that here. Okay, we just want one array though, not a nested array. And now that we have our ABI, let's get the address. And that is our contract address. Okay, so we can kind of close some of these files and paste in the contract address. Now we are finished with this contract.js file. Let's close this. Okay, and we're going to go to app.js. Now, inside of app.js is where we're going to handle kind of connecting to MetaMask. And this is a little bit complicated, but what we want to do here is make it so that kind of whenever this app component is re-rendered, which I'll show you how to kind of handle in a second, we check if we're currently connected to MetaMask or not. So we want to actually kind of do a check, which we haven't done yet, and say, okay, if we're already connected to MetaMask, we don't need to prompt the user to connect, but if we're not, then, well, we want to connect. So I'll show you how we set that up. Then once we do that, we need a function that's going to actually allow the user to connect to MetaMask. And then we want to kind of hold this state in our app, component that tells us, are we connected to MetaMask? Are we a member? Etc. Right? So you'll see what I mean. It's a bit vague so far, but that's the idea of what I'm about to try to write. So what I'm going to do here is I'm going to say import. I'm going to import some things from React. I'm going to import useState and useEffect. Now these are referred to as hooks, and I'm going to import this from React. Next, I'm going to say import, and I'm going to import connect and get contract from, and this is ./contract, like that. Okay. Now inside of app, I want to store 3 pieces of state. Now when I use this useState hook, essentially what this means is that anytime I update my state using a special function, which you're going to see, it'll automatically re-render my component, which is what I want, because when I re-render a component, that means I kind of redraw it onto the screen. So if I've changed the name of a button, or I'm, displaying something or not displaying something, that gets automatically updated for me when the state changes. So that's why I'm using this state here. So I'm going to say const, and we're going to say connected, and then set connected is equal to useState. And that's going to start out as false. So connected is the state, and then set connected is the function we use to update the state, which forces a re-render. Next, I'm going to have const, and this is member. And then we're going to have set is member, and this is equal to useState false. And then I'm also going to have one more piece of state, and this is going to say contract and then set contract, and this is going to store the instance of my contract that I can be using to actually interact with my smart contract, as that makes sense. Okay, now what I'm going to do is I'm going to write the useEffect hook. Now what useEffect takes is a function, so I have to put a JavaScript function here, and what's known as a dependency array. Now I'm not going to put anything in this dependency array, and what that means is that this useEffect function or hook, whatever you want to refer to it as, the function side of here essentially, is going to run every single time that I kind of first render this app component. So when I first load my React website, or I refresh the website, for example, useEffect is going to run. And what it's going to run is essentially checking if I'm connected to MetaMask or not. If I'm connected, it's going to kind of set the connected state and do any initialization, that I need to. Otherwise, it's going to say, well, you're not connected, and it's going to show that we need to connect on the nav bar, which I'll show you in a second. So the way I check this is I say window Ethereum dot request, and this is really our provider, right? Like, our MetaMask provider in a sense. So I'm saying window.ethereum.request, and then I'm going to say method, and this is going to be eth_accounts, which we've used before. And I'm going to go here and say .then, and I'm going to say async accounts, okay? And I'm going to now look at my accounts. And actually, I don't know why I put async here. I don't need to have async. I'm going to say if accounts.length is greater than 0. Now, what this method returns to me is all of the accounts that I'm currently connected with. I could be connected with multiple accounts, could be connected with one, etc. So I'm saying if I'm connected with at least one account, which is what this if statement is checking, then I'm going to call a function called handle_init, which we'll call in a second. Otherwise, so else, I'm going to say set connected, and I'm going to set it to false. Now, that's just in case we were already connected, so I'm just kind of explicitly setting it here. And that's all I need inside of this use effect. Now we're going to write this handle_init function. So I'm going to say const handle_init. Okay, this is a function, and this is what we want to do if we are connected to MetaMask. So the first thing we want to do is want to say set connected, and then we're going to pass true. Remember, that's the function we use to update our state. So I'm setting this to true. Next, I'm going to say const contract signer, and sorry, this needs to be in curly braces, not square brackets, is equal to, and then the get contract function, and that get contract function, remember, is from our contract.js file. Okay, so going back here, we're calling get contract, so we get our contract and we get our signer. Now we're only doing this if we are connected to MetaMask, right? So if I'm already connected, okay, go ahead and get the contract. The other function that we have is going to be to actually connect us, which I'll show you how we do in a second. All right, so if we're connected, we do this. We're going to say set contract, and we're going to set it as the contract. Now, the reason I'm doing this is that I want to store the contract here so that, again, I can kind of pass it around and use it as I need to. Okay, now what I'm going to do is I'm going to say if I had a contract. Now, there's some kind of weird cases where you may not get a contract object. The initialization may fail. So I just need to do this to make sure we don't run into any of those edge cases. I'm saying, okay, if we actually do have a contract, if this is not null, if we got a contract object, then what I'm going to do is say signer dot get address dot then. I'm going to say address like this, and I'm going to check if I am a member. Now, the way I'm going to do that is I'm going to say contract dot members address dot then result, which is going to tell me if I'm a member or not. And then I'm going to say set is member and then result. Okay, so let me break this down. I know this is a bit complicated, but I'm getting the address of my signer, which is the account that I'm connected as. And then I'm saying dot then, so I'm just waiting to get the address essentially. So I get the address here, and then I go, okay, I have my contract, which is my voting contract, and there is a mapping called members. So what I can do is I can directly call the mapping, assuming we've made it public, which I'll actually have to go back and check if we've done, with my address. When I do that, it's going to return to me the value stored at this kind of key in the mapping, which will be true or false, telling me if I'm a member. So if I'm a member, well, regardless of if I am or if I'm not, I want to set that and kind of update that in my state. So if I am a member, tell me I am by setting it to true, otherwise set it to false. And now I can update the nav bar and only show become a member if I'm not already a member. Great. So let me just go to voting here quickly. So yes, inside of members here for my mapping, I'm just going to specify this as public. Now, unfortunately, what that means is I need to redeploy this. So I am just going to rerun this script here to redeploy my smart contract. The ABI shouldn't change, but the address is likely going to change. So I'm going to go to voting now, and I'm just going to grab this new address and take that and put that inside of my contract.js. Okay, so you kind of have to always be updating this address based on how your node is running or where the contract is stored. Anyways, hopefully you get the idea now. So now our new contract should have been deployed. And now that this is public, I can access this mapping and kind of get values out of it. All right. So now we have most of what we need inside of app. However, what I'm going to add is a function that allows us to connect. So if we're not connected, well, now we need to be able to connect. So I'm going to say const connect like this, and I'm going to call it callback. The reason I'm calling it callback is I'm going to be passing this through a prop, which I'll show you in a second. Now, this is going to be an async function. And I'm going to say const, And then this is going to be contract is equal to await, and then connect. And recall that connect is the function that we have inside of contract.js, okay? So what I'm doing is I'm returning get contract from here, but I only care about the contract. I don't care about the signer. So from app, I just grab the contract after I connect, and then I say, set contract. So here, set contract. I set the contract, and then I say if contract. So if it's not null, then I can say set connected and set that to true. Okay, so that is my connect callback. Lastly, while we're at it, I'll actually just write a function that allows us to become a member. So to become a member, I'm going to say const become member is equal to an async function. Okay, and I'm going to say if not contract, then I'm just going to set alert here, and I'm going to say please connect to MetaMask. So for some reason, some weird error happens, and we don't have access to a contract here, then we're not going to be able to use it. So I'm going to say please connect, and then return. Otherwise, though, I'm going to say await contract dot join. Remember, that's the function on our contract. I'm going to say dot then, and for dot then, I'm just going to have a function here. I'm going to say alert joined, and then I'm going to say set is member equal to true. Okay, and then we can do a catch just in case something goes wrong. We'll say error, and I will say alert error dot message. Okay, so now we have pretty much all the functions we need to kind of connect and become a member. Now we need to actually call them and use them. So what I'm going to do is go here to my nav bar, and I'm going to pass 4 pieces of state. Now, the first function I'm going to pass is connect. So I'm going to say connect is equal to the connect callback. Okay. Next, I'm going to pass connected is equal to my connected state, telling me if I'm connected or not. Then I'm going to say become member is equal to the become member function. And then is member is equal to the is member state. Now, again, all of this data is going to become available in the nav bar, which I'm going to show you how to access. And this is going to allow us to kind of pass all this data through and then use that to only show the appropriate buttons and to make the buttons actually do something when we click on them. So now we're going to go to the nav bar. And inside of our kind of function here, our parameters here, we're going to write our curly braces. And that's because our props come in as an object. So what you'll typically see here is props. And then this is equal to a JavaScript object that has the different keys equal to the values you passed. But in my case, I just want to directly strip out the props that I want, which are going to be my connect function, my connected state, my become member function, and then my is member state. Okay, so I've got all of those now. Now that I have those, I want to be using them inside of here. So for example, for become member, if we click this, so on click, I want to call the function that is become member. Okay, very straightforward. However, I only want to show this button if I'm not already a member. So I'm going to say not is member and then I'm going to take this button here. I'm going to put it over here. Now this is using the logical short circuiting, kind of rules where what I'm doing is I'm writing JavaScript in line. So this is what you can do inside of JSX, which is what you're returning from a React component. So this is kind of how I can write conditional rendering syntax. So this means if I'm not a member, then I will render this. But if I am a member, then we're going to short circuit, which means I'm not going to do this. So it won't show this on the screen. So it's kind of a shorthand to conditional render. And for me to be able to write my JavaScript, I need to write it inside of a set of curly braces. So that's what I've done here. Hopefully that makes a bit of sense, but this is just only going to render the button if I'm not a member. Okay, now for connect to MetaMask, we're going to say on click is equal to connect. But again, I only want to show this if I'm not already connected. However, I want to show something else if I am connected. So I'll show you how we do that now. So I'm going to say connected question mark, use my conditional operator. And I'm going to put that here. And I'm going to say colon. And instead, I'm going to render a p tag. And inside the p tag, I'm going to say connected to and then MetaMask like that. And I'm just going to add kind of an inline style here. I'm going to say style equals color and then white. Okay, now it's important you do 2 sets of curly braces here. The first set is to note you're writing JavaScript. The second set is a JavaScript object, and I'm saying the color is white, so just going to make this text white. Okay, so I hope that that is clear. I'm going to just add a capital here for MetaMask. Now, though, our nav bar should be working. And sorry, this needs to say connected. So if not connected, question mark, then I'm going to do this. Otherwise, I'm going to show this. So I'll be showing one of the two here. All right, let's rerun our code. Now to do that, I'm just going to cd ... cd into my front end, and then npm start. And then it should open this up for me automatically. Okay, so I've gotten a small error here inside of my src contract.js. Let's have a quick look here. It's saying for some reason ethers is not found. Now I thought I installed ethers, but maybe I did not. So let's just run the installation again. I'm going to type npm install -- save and then ethers. Again, inside of my front end directory. Let's just make this a little bit larger. And ideally that should install that for us. It looks like it was already installed. Okay, let's run this one more time, npm start, and see if this is going to work now. All right, so I got the same error here. Now, it actually looks like the error is that I have provider rather than providers. So there we go. I just need to change that. And now I think we should be good to go. Okay, so there we go. So now it's rendering properly. And notice here that I'm already connected to MetaMask. Okay, great. Now, if I go to MetaMask, the way that I can kind of manually disconnect here is I can click on this button and click on disconnect this account. Now, it's not going to live update here, but what I can do now is refresh, and notice now the button connect to MetaMask is here. Now, if I press this, it kind of opens up MetaMask, and it's going to ask me what account I want to connect with. Let me connect with this account here. Okay, that's fine. So I'm going to connect, and there you go. Now it changes to connected to MetaMask. Now, I'm not yet a member, so what I can do is click become member, right? And then I can run my MetaMask transaction. So let's go ahead and do that. And we got an issue here. It says received invalid block. Okay, so usually when you get that kind of issue, it just means you need to reset your account. Again, just kind of a bug that happens when you keep starting and stopping the server. So I'm going to go here, settings, advanced, reset. Okay, let's refresh. Let's go become member. Please connect to MetaMask. Okay, let me refresh. All right. Okay, getting an issue here. Let's go to MetaMask. And it does say that we're connected. Okay, this is a little bit weird. Refresh. Please connect to MetaMask. Okay, let's rerun. Okay, so let me just go to MetaMask here. Let me disconnect. Okay, refresh. Let me reconnect. All right, next, connect. Okay, now become a member. And let's see if this is going to work. And confirm, and there we go, we have now joined. Okay, so I just need to reset the account and then kind of rerun the website here. All seems good now. All right, so sorry guys, I was just kind of messing around with this and realized that I had a quick bug that we needed to fix. So I'm just going to go into my app component, which I'm already in here, and notice that get contract here is a promise. So what I'm going to do is I'm going to say get contract dot then, and rather than having kind of contract and signer like this, I'm just going to say dot then, and then I'm going to grab my contract and my signer, and I am going to have a function, and inside of this function is where I'm going to run all of this. Okay, so get contract.then, we're going to wait for the result, which will actually make sure we have access to the contract. We're going to set the contract, and then again, if contract, we're going to check if we are a member or not. So I was having an issue previously where this wasn't running because the promise was not resolving in time for this to be able to run on this kind of handle a init call. All right, so now that we fixed that small bug, there's also one more bug I just realized we're going to have, and that's going to be with the contract ABI. Previously, I didn't have my members mapping marked as public, but now I do. So I'm actually going to go back to my deployment info here and notice now that I have this members kind of ABI function. So I'm just going to copy that, go here to contract. I'm going to paste this in. So now, hopefully, when we call this function, it should be recognized and everything should be working fine. Okay, I apologize for those mistakes, but that's what happens when you're writing kind of front ends for blockchain development. Anyways, let's go back to our front end now with those bugs fixed. Let's refresh and notice that this become member function is no longer showing up because it knows that we are a member. We've already kind of connected and became a member. Perfect. Now, if we were to disconnect from MetaMask and then connect with a different account that wasn't a member, it would show that, of course, for us, but that's kind of what we worked on, dynamically rendering those buttons. Great. Now that we have all of that, let's see how we can create a vote. Then once we can create a vote, we'll display the votes and actually be able to vote. So let's go to the create vote component. And one thing we want to take in as a piece of state for create vote is the contract. So we're going to go back to app actually here, and we're going to go to where it says create vote, and we're going to pass as state here, whereas props, contract, and then contract. So we have access to the contract, and we can call the create vote function. Okay. So inside of create vote, what we need to do is create a form. Now there's a variety of ways to do this, but I'm going to be using Bootstrap. So I'm going to go to the top, and I'm going to say import button from React Bootstrap. Then I'm going to say import form from, and then this is React Bootstrap /form. Then I'm going to say import use state from React. Now, all of the kind of inputs that we need to collect here when we're creating a vote, I need to store in state so that I can access them at any time. So I'm going to say const URI, and then this is going to be set URI is equal to, by default, an empty string. Okay. Then I'm going to say const options. This is the number of options, right? And I'm going to say set options is equal to use state, and we'll set that as a default of 2. Then I'm going to say const end date set end date is equal to use state, and I'll just make that an empty string for now. Okay, so now that we have our state, we want to write out the kind of HTML or JSX for the form. So I'm going to go return, and I'm going to specify a form from Bootstrap. Now for the class name, I'm going to say this is M2, which stands for margin 2, which just means we're going to have margin of, I believe it's something like 10 pixels. I don't know the exact units on every single side of our form, just kind of space it out from the edge of the screen. Now I'm going to create an H2 here just as a header for the form. I'm going to say class name is equal to dflex, which means display flex. Then I'm going to say justify content center, just to put this in the center of the screen, horizontally, sorry. And then I'm going to call this create vote. All right. Next, we want to create a few form groups. These groups are going to group each one of our individual inputs. So I'm going to say form.group. And for the class name, this is going to be M and then -2, same thing, just margin on each side, just kind of space it out from the other elements. And I'm going to put inside of here a label. Now the label is going to have HTML4, and then this is going to be equal to URI, which is going to be the ID or kind of the name of the form control element, which you're going to see in a second. And first of all, we're going to have IPFS URI like that, okay? Then we're going to have our form.control, which is essentially an input field. And this will be a self-contained component. We're going to have the type of this being text. We're going to have the name being equal to URI. We're going to have the placeholder be equal to IPFS URI. Okay, and then we're going to have the value, which is important, be equal to URI. Okay, lastly, we're going to have an onChange function. So this is what happens when we change this input. And we're going to say E, which is the event related to the change. And then for this, we're going to say set URI, and this is E dot target, which is the kind of input itself, dot value. I know this might seem a bit confusing. This is essentially how you update this URI state, which is going to be the value of this component whenever we change what the value is inside of this form box. Okay, now we're going to copy this. I'm going to paste this because for the next input, we're going to have a similar thing, except this time it's going to be the number of options. So I'm just going to change a few things. I'm going to say number of options. Let's end our label here correctly. Okay, /label. This is going to be HTML4, and then we're going to say options. We're going to change this to be options. Placeholder, we don't actually need anything there. Value, this is going to be options. Rather than set URI, this is going to be options. And then the type is going to be number. And I'm going to say the min value here is equal to 2. And the max value here is equal to 8. Okay, so that should give us our number of options as well as our IPFS URI. Lastly, I want my end date. Now for the end date, same thing. I'm going to copy this and paste. For the label, we're just going to call this end date. This will be for end date. Type here is going to be date. We can get rid of the min and the max. For the name, this will be end date. For the value, end date. And then on change, set end date. Okay, perfect. Now, last thing we want is another form control. So I'm going to say, or sorry, not form control, form group. This time, the class name is going to be equal to M2, again, margin 2, and then MT4, which is going to set margin top 4. So just spacing this out a little bit more from the rest of our inputs. And inside of here, we're going to put a button. Now, by the way, all of these class names come from Bootstrap. Okay, so for the button, I'm going to say variant, if it spells correctly, is equal to success, just to make sure this is green. I'm going to say on click with a capital C is equal to, we're going to call a function called create vote, which we're going to write in a second. And for the text, we're going to have create. Now, let me just stub out this function so we don't get an error. I'm going to say const create vote is equal to, and then we're going to have a function. Perfect. All right, so let's just have a look at our website here, which should have been automatically updating. Let's go to the create vote page. And there we go, we get a nice little form. I mean, not ideal, probably could look a little bit better, but I think for our purpose, this is fine. So what we want to do now is make it so when we press this button, it actually does something, right? It creates a vote. So let's do that. I'm going to go create vote. First thing I'm going to do is I'm going to say, if we don't have a contract, that means we're not connected. So if this is null, that means we're not yet connected. So I'm going to say alert. I'm going to say, please connect to MetaMask. Okay, then I'm going to return. All right, next, what I'm going to do is I'm going to say await contract dot create vote. I'm going to call this function, and I'm going to call it with the URI, the date dot get time. Now, when you call get time on a JavaScript date object, which is what this object is going to be, our end date. Sorry, this is end date. What it's going to do is give you the UTC timestamp, which is exactly what we want to be submitting to the blockchain. Okay, so we get URI end date dot get time, and then we're going to pass options. Okay, and then I'm going to have a dot then. For my dot then, I'm going to say alert, and then this is going to be success, just telling us, okay, this was good. And then otherwise, I'm going to say dot catch, and for the dot catch, I am going to say error, and then alert, error dot message. Now I'm getting an error here, and that's because I need to make this an async function. So let's change that, and now our formatting happens, and everything looks to be good. Okay, so fairly straightforward. We're just calling the create vote function, passing our URI, our end date dot get time, again giving us that UTC timestamp, and then the number of options. Great, so that is create vote. Now we can actually test this out because it should just be hooked up and working. So let's refresh. Okay, I'm going to go IPFS URI. Now, at this point, let me actually show you how we kind of create IPFS data without using that Minty contract. So what I'm going to do is go to a website called Panita. Again, it's panita.cloud here. This gives you 1 GB of free data, so you guys can just kind of sign up and create an account. Let me sign in with my account, and I'll show you how simple it is to get an IPFS URL from Panita. All right, so I've signed into my account here, and you can see that I actually already have some data that I've uploaded, and I think I showed this previously when I was kind of demoing the project. Now, what you can do here is just press this upload button from the Pin Manager tab and upload a file, and what you're going to want to upload is a JSON file. Now, the JSON file needs to be in this format. I'll just kind of zoom in a bunch so you can see it. We want to have a description, and then our options. So the description is whatever kind of the name of the vote is, and then the options is whatever the options are for the vote. So what you can do if you want to create a JSON file is you can go to Visual Studio Code. We can kind of just dump one anywhere. So I'll make a new file here. Let's call this, vote1.json. Okay, and inside of here, we're going to open up our curly braces. We're going to say description, and then we're going to say options, and then we're going to list our options in our description. So for the description, I can say, who is the best programmer, question mark. For the options, we can go with the correct answer, which is Tim. We can go with Clement. We can go with Antoine. like so. Okay, so there you go. We now have a file that we can upload to IPFS. So if we want to upload that now, we go to Panita, we go to upload, file, find the file, and upload it. So I'll actually just use ones that I already have uploaded, but you guys can obviously just follow the process I showed you, and then you need to wait a second, and what you can do is click on view. When you do this, you're going to get the whole URL using the Panita gateway. But what I will do is just take the IPFS section, right? So IPFS/, that's the only part that you need. You don't need the gateway aspect. I'm going to copy that, go here to decentralized voting, paste that in, and then hit create once I set the correct number of options. So here we have 3 options, right? Let me verify that. Sorry, we have 4 options. And for the end date, I'll just set it kind of arbitrarily in the future. It doesn't really matter. We're not going to be testing that in this video. Okay, so let's go to create vote, or just press create. Okay, it's going to take a second, ideally. Then it should tell us that this was successful, unless I'm getting some kind of error here or it's not working. Seems like it's actually not calling this. Maybe I didn't set this up correctly. Let me go to inspect here and see if anything's wrong. I'm going to go to console, and it got an issue. It said enddate.getTime is not a function. Okay, so I think what we're going to need to do here to fix this is we need to go to create vote, and we're going to say new date, enddate.getTime. Now, what this is going to do is going to convert this enddate into a date object, a JavaScript date object, then get the time for it, then submit it. Okay, so let's try that. Let's go back here now. We can refresh, I guess. I'm going to paste in this IPFS URL. 4 options, end date, again, arbitrarily in the future. Then hit create. And let's see if this works. Okay, so now let's go confirm. And success, it has now been created. All right, so now that we have done that, the last part of the video is to actually display our votes and to, well, be able to vote. So let's start working on that. So I'm going to go over here to votes. And I won't lie to you, it is a bit complicated to display the votes, but the basic process is going to be that we are going to kind of query all of the logs or all of the events from our contract. We're going to find all of the votes that were created. We're then going to get all of the current vote data. So all of the, like, who voted for what option, the URI, so the data. We're going to go to the IPFS gateway using Panita. We're going to get the IPFS data, which will give us the description and the options for our vote. We're then going to display all of that onto the screen. So to do this, first of all, we're going to say import, use state, and use effect from React. We're then going to say import, and we're going to import a button from React Bootstrap. We're going to say import card from React Bootstrap /card, and we're going to import a progress bar from React Bootstrap /progress bar. Okay, so this is what we need in terms of components. We're going to render every single one of our votes as a card, and then all of the kind of like individual votes or options, we're going to have a progress bar for showing those. Now, before we render anything, I want to focus on getting all of the votes, and we want to do that every time we load the votes page. So we don't want to have a button that's like kind of like updates our votes. We just want it to automatically happen. So the way we can do this is we can say const votes, and then set votes is equal to use state. And we're going to have an empty array because we're going to have, well, a list or an array of votes. Now, I'm also just going to set const gateway equal to the Panita gateway, which I'm just going to copy in here just so we have this kind of set already, because we're going to use that to access our IPFS data. Remember, Panita is a pinning service, and it's going to make sure our data is always available on IPFS and that we don't have to host it locally like we were when we were dealing with our NFTs. Okay, now I'm going to say use effect so that we're going to run this right away, essentially. And I'm actually going to take as a dependency the contract, which I'm going to take as a prop here to votes. Now, the reason I'm passing this is that if I connect to MetaMask while I'm on the votes page, and now all of a sudden I have a contract, then I want to update this use effect. I want to run this use effect hook. So what happens is this function will run anytime anything inside of this dependency array changes. So if it goes from false to true or true to false, etc. Now, if you have an empty dependency array, it means this just runs one time on the initial load of this component. But in my case, if I update the contract to that changes, then I want to, well, run this use effect hook again. So the first thing I'm going to say is if not contract, then return. I don't want to do anything if I don't have a contract, because I'm not going to be able to use my contract object. Otherwise, I'm going to say const filter is equal to contract dot filters dot vote created. And what this does is give me a filter that's going to give me all of my votes. So every single vote that was created will give me all of those events. That's what it does. Now, you can specify inside of vote created any specific values you want the different topics to be equal to. However, I'm not going to be doing that here. So if you just wanted to get all the votes created by a specific user, then you would pass the address of that user as the first argument here, and then it would only give you those. So you can do all kinds of advanced filtering. I'm not going to show that here. You can go back to interacting with smart contracts, and you can see kind of how we've done that. All right, so I'm going to go contract dot, and then the function is query filter. And we're going to pass our filter. We're going to say dot then result. And then what we're going to do for now is just console.log the result, just to see what we're getting, and then we can see how to work with that data. So I'm going to go now to my votes page. I'm going to refresh, and we should see that we get something popping up in our console. For some reason, we are not, which is a bit surprising to me. I'm just going to rerun this here. So nothing is appearing, but I don't see any errors. Okay, interesting. So for some reason, this use effect doesn't seem to be working, maybe. We can add a .catch and say error, and then just console.log the error. It's also possible that we just don't have access to the contract, and actually, that's going to be the bug, and sorry about that, because we forgot to pass our contract to our votes component. So let's go back here and pass that. Okay, so now this should be working. Let's go back here, let's refresh, and let's look at the console, and notice that we have some output here, and we have the transaction logs, or the transaction event that we used when we created, or emitted, sorry, when we created our first vote. So if we go in here, we can see our first index, we have the address, and then we have args. Now what we're looking for is args. Now args is going to give us the information that is contained in the log. So the first thing is the user who created this vote. The next thing, I believe, is the vote ID. Then I think we have the created at time and the end time, or something along those lines. So I think it's end time and then created at. I'll talk about that in a second. Anyways, there you go. You can kind of get the information here that is popping up. And in fact, actually, it says 0, 1, 2, 3, 4, which are the args. And then down here, it actually gives you the named arguments. So we have created at, end time, owner, vote ID, which is actually interesting. I didn't realize we had access to that all kind of in args. So we'll just use the named arguments, created at, end time, owner, vote ID. Perfect. So let's go back here and use those. So what we're going to do is go to votes. And now I'm going to write a function. I'm going to say const set votes data is equal to async votes like this. And now we're going to start writing some code. Now, here, what we need to do is we need to take every single one of the logs that we have, every single one of the events that we have, which are all the votes that were created, and we need to get the IPFS data and then kind of store that in a readable format for us. We also need to get all of the vote data and a bunch of other stuff. So there's more operations rather than just reading the transaction logs or the transaction smart contract events, whatever you want to refer to them as. So what I'm going to do here is I'm going to set up two lists or two arrays. I'm going to say const promises equal to an empty array. And then const new votes, same thing, equal to an empty array. So I'm going to say for, and this is going to be const vote of votes. Okay, and I'm going to say const, and then this is going to be, and what do we call this? Creator vote ID, created at, and end time is equal to the vote.args. So we're going to parse that out. Now, let me just make sure that's correct. We have, sorry, not creator, we have owner. That's what we called it. So let's change this to be owner, like that. Okay, so we're going to get that information from the individual vote arguments. Once we have that, what we want to do is we actually want to get kind of the updated vote data from the smart contract, right? Which will give us who's voted, you know, what votes are currently, or what options have what votes. That's what we want. So I'm going to say const promise is equal to contract, if we can do this correctly, dot get vote. I want to get the vote equal to the vote ID. We're going to say dot then. We're going to have an async callback function. This is going to take in our vote data. And now we're going to get what we want from our vote data. So we're going to say const URI is equal to vote data 0. That's the first thing that's returned when we call get vote. We're going to say const current votes is equal to vote data, and then this is at index 2. And then we're going to say const current vote, and then this is going to be numbers, current votes numbers, sorry, is equal to, and I'm going to say current votes dot map, and I'm going to map each value to its numeric representation. Because remember, when we get numbers out of our smart contract, they come as a big int or big number. We need to then convert those to a regular JavaScript number to work with them. So we're calling the isNumber function on every single value that's inside of our current votes array so we can actually use it properly. Hopefully that makes a bit of sense, but that's what we need to do there. Okay. Now that we have that, we're going to craft a new vote object that is what we're going to actually store and kind of use on our front end. So I'm going to say const new vote. I'm going to say ID is equal to the ID.to number. Okay. And it's not ID, it's vote ID. And this is not a semicolon. This is a comma. Next, we're going to have the owner, which is the owner. We're going to have created at, and this is going to be created at dot to, and again, number, because this is going to be a timestamp, so we need to convert that later on. We're then going to say end time, and this is going to be end time dot to number. We're then going to have total votes, and what total votes is going to be is the sum of all of the votes. So I'm going to say current votes numbers dot reduce, and then this is going to be sum value, and then sum plus value, and we're going to start at 0. And then lastly, we're going to have votes, and this is going to be equal to the current vote numbers. Okay, I know that was a lot, but we're essentially just getting all the information that we actually need, storing that in an object. And then the last thing we need to do is we actually need to get the vote data, right? So we need to get the URI from IPFS, so we get the description and the options. So I'm going to say if not URI, then return, because if we don't have a URI, then what that actually means is that we don't really have anything to vote on. So I'm not even going to bother kind of processing this anymore if there's no URI. And in fact, I can probably save myself a bit of time here by just kind of going up at the top and saying, okay, if there's no URI, don't even bother doing the rest of this stuff because I don't need to, right? If this, if this vote just doesn't have URI data, then I'm not going to do anything with it because I can't really display a vote that's empty. Hopefully that makes a bit of sense. Next, what I'm going to do is I'm going to have a try catch block. It's important you have this try catch block because unfortunately we cannot verify that an IPFS URL is correct inside of a smart contract. At least we can't do that in an efficient manner. So we can potentially have kind of broken IPFS links, or we can have links that aren't even to IPFS data. So what I need to do here is attempt to fetch the URI, which is our IPFS data. But if that data is invalid or doesn't exist, then I need to kind of handle that exception that's going to be raised. So that's why I'm putting that in a try catch. Now inside of here, I'm going to say await fetch, and I'm going to fetch my gateway, which is the Panita gateway, plus URI. I'm going to say dot then result, and then I'm going to return my result.json. And then I'm going to say dot then again, and then this is going to be my data, which is now actually usable by me in JSON format. And I'm going to say my new vote dot description is equal to my data dot description. And then I'm going to say my new vote dot options is equal to my data dot options, which we're expecting. Again, we can't verify this is going to be here, but that's what we're expecting is in the IPFS data. Then we're going to say new votes dot push, and we're going to push our new vote. All right, and then that's all we need here. And then lastly, kind of outside of this promise, which is all of this code right here, we're going to say promises dot push, and then we're going to push the promise. And the reason we're doing this is so that now we will kind of load all of these at the same time asynchronously rather than waiting in queue synchronously. So I know this was a lot of code. Feel free to pause the video, kind of read through it if you need to. But essentially what we're doing is we're taking the data that we have from our event logs. We are then creating a promise where what we're going to do is attempt to get our vote data from the smart contract, which will be the up-to-date data from the blockchain rather than from our events. We're getting vote data, right? Grabbing our URI. If we don't have one, we're going to return. Otherwise, we're going to craft what we need for our kind of vote that we're going to be displaying on the front end. And then we're going to go and attempt to fetch our IPFS data. Now what I need to do that I have promises.push, at the end of my function here, I'm going to say await promise.all and then promises. And then I'm going to say set votes here. And I'm going to set my votes to be equal to my new votes, which is where I'm going to be pushing all of my vote data. Now I'm going to go to here inside of my use effect, and rather than calling console.log result, I'm going to say set votes data, and I'm going to pass my result. Now, if I would like, what I can do is print out my votes, or I can just start rendering them on the screen, which is what I'm going to do now. Okay, so I know, again, that was a lot of code, but now we've done kind of the hard part. Now what we need to do is just render this data on the screen and then allow a user to vote, which is actually fairly easy. So what I'm going to do is return a div here. That's fine. And inside of this div, I'm going to take all my votes and I'm going to map them to components I'm going to render on the screen. So I'm going to say votes.map. I'm going to take my vote, which is going to be all my vote data, and I'm going to return a card. Now, for the card, I need to have a key. This is just so that I have a unique identifier for each kind of dynamically rendered object. This is a React thing. For the key, I can just make this the ID of the vote because I know that will be unique. And I believe, did we call this, is it ID or is it, yeah, I think it's just ID. Okay. Then we're going to say class name is equal to my2, which means margin vertical 2. Then we're going to have a card.header. Inside of the card.header, I'm going to have the description of the vote, which is kind of like the title of the vote. Then I'm going to have a card body. And inside of the body, I'm going to have all of the different options. So I'm going to say vote.options. Then it's going to be .map. I'm going to map my option and my IDX to the following div. So I'm going to say div class name equals MT1, which is margin top 1. Again, since I'm rendering this using a map function, I have to have a key. So I'm going to say math.random plus IDX. Okay, and then I'm going to specify what the option is. So I'm going to say option, which is going to be kind of the value or the name of the option. And then this is going to be to an empty space. And then I'm going to have here a bit of complex logic. I'll explain this in a second. Vote.votes at IDX divided by the math.maximum of 1 and vote.total votes. And then I'm going to multiply all of this by 100, and I'm going to put a % sign. Now, again, let me just break this down for a second. So option here, when I go through my options, is going to be the string option that I'm voting for. IDX is the index of that option, and having that index allows me to look up how many votes this option has from the votes array of my vote, right? So that's what I'm doing. So I'm getting this, I'm dividing by the total number of votes, which we already calculated, and multiplying it by 100 so I can get a percentage. Now, the reason I need math.max is because this could be 0, and then I get a division by 0 error, which is going to give me in JavaScript not a number, like nan is what it actually is, the type for that, and that's obviously not going to look good on the UI. So instead of having nan, we're just going to display 0, which is why I have this, again, math.max of 1 and vote.total votes. Okay, now we have that kind of top, this is what I'm going to call like the label for our, what do you call it, option. Now we want to display a progress bar. So I'm going to say progress bar, and for our progress bar, we can actually just make this a self-contained component. We're going to say now is equal to, and then again, I'm going to copy this whole thing and just kind of paste it inside of here. And I think, yeah, that's fine. So we're just taking the percentage. So now is going to be a number between 0 and 100. That's what you pass as kind of the main prop here to progress bar. Now we can also have a label. Now for the label, I'm going to make this a bit simpler, and I'm just going to make this B, actually has to be a string. So I'm going to pass backticks. I'm going to pass a $sign in my squiggly brackets. I'm going to say vote.votes at IDX, and this will display the number of votes. And then lastly, I'm going to have class name is equal to, and I'm going to do W100, which stands for, width 100. And then I'm going to do ME2, which stands for margin N2, so it just gives a bit of space at the end. All right, now this progress bar is going to sit inside of a div. So let's put a div around it. And for this div, we're going to make it so that the contents are aligned horizontally so that we can have a button to the right-hand side of our progress bar. So I'm going to say display flex, W100, which is width 100, and then align item center, which is going to align our button and our progress bar vertically. Next, I'm going to put a button. This is going to be the vote button. Now here, we're going to say size is equal to SM, which is small, of course. I'm going to say on click is equal to, and we're going to call a function. We're going to do that in 1 second. So right now, I'll put an empty arrow function. I'm going to say variant, which is really just the color, is going to be dark. It's going to make this kind of like a dark gray black button. For the text, I will put vote. Okay, that wraps up our card body. And I think that's all we need for right now. We can also display like when the vote ends if we want to do that, but I'm going to stay away from that for right now. So let's go back here and let's refresh. And we got an issue here. It says val.isNumber is not a function. Okay, so let me see what the problem is here. Where do we have isNumber? This actually needs to be toNumber, not isNumber. So let's change that here. Let's go back to this page. And now notice that we are rendering our vote on the screen. Perfect. Last thing we need to do here now is make it so when we press the vote button, it actually votes. So let's do that. We're going to write a function. Let's say const. We're going to have this be vote, not called, vote pressed. Okay, this will be an async function. And what are we going to do inside of here? Well, we are going to say await contract dot, and then this is going to be vote. And then what we need to do for our vote is we need to know what vote index or what vote ID, and then the option IDX. So I'm going to say ID and then option IDX. I'm going to pass those accordingly. And then we're going to say dot then, and then we're going to do an alert, and we'll say success. And then again, we can have a catch here. We can say error, and then we can alert the error.message. I'm sure you can handle the errors better, but I think for simplicity here, this is fine. So we're going to say error.message. Okay, now let's go and let's call vote pressed. I'm going to actually go inside of this arrow function. I'm going to say vote pressed, and I'm going to pass my vote.id, and then the IDX, which is the index of the current option that I'm rendering, which is what I'm doing kind of inside of here, right? So this map function is rendering every one of our individual options. For each one of those options, we have a button, but each one of those buttons calls a different vote, like it votes for a different option. So we need to pass that index as well as whatever vote it is that we're actually voting for. So we need the ID of that. Okay, so that should about be it. Yeah, I think that's actually all the code we need to write. So let's test this out now and make sure it works. So I'm going to refresh, and let's try to vote for Java. When I do that, it brings up MetaMask. Okay, let's click on confirm, and then we get success. Now, what we could do if we wanted to, I'm not going to do this, but what you could do is make it so that as soon as you press that vote button, you update on the front end this so that it doesn't look like your vote didn't go through. The problem is that the blockchain is going to take a second to actually propagate this information. So what I will need to do is refresh the screen, and now it will update. However, it could take a few seconds to update. And since what I'm not doing here is listening for events, I'm not listening for a vote event to go through, I'm not automatically updating this, which requires us to do a refresh. Now, if you wanted to get a bit more complicated, again, you could be kind of listening for different events to occur. And when they occur, then you can update this information yourself. I don't want to get into that because that's a whole bunch more code to be writing here for this project, but that's how you could extend this if you wanted to make it a bit more live. And then that way, anytime votes come in from other people as well, not just you, you'll kind of see them popping up here. For now, though, I think it's fine to just refresh. And again, you kind of can keep in mind what you would need to do to make this more live updating. So let's create another vote and just make sure we can vote for that one. And I'll use an existing kind of piece of data that I have here. So like, what is the best? Well, I've already done that. So let's use this one here, which is who is the best programmer. So I'm going to copy that one. I'm going to go back to create vote, paste this in. This has 3 options. For the end date, again, we can go arbitrarily large here. Let's create this. Oops, want to go back to MetaMask. Okay, confirm. Success. Go back to votes. And again, it's going to take a second here to update. And there we go. Now we have who is the best programmer. Let me try to vote on this one. Let's vote for Tim. Okay, confirm. Success. And then again, we're going to have to wait about 10 seconds here. And then this should update. Okay, let's see if it goes through. All right, and there you go. Tim is now updated. Now you can see if I try to vote, say for PHP, I get an error. You can kind of parse through this error if you want. I just did this for simplicity, but you can kind of find the reason. VM exception while processing transaction reverted with reason string. You have already voted, right? So it's telling us why we can't do that. You could also do something where you check if the user has already voted or not, and then you could make this vote button disappear. Again, kind of beyond the scope of this tutorial. So what I want to do now is disconnect MetaMask and connect with a different account, and then show you that I can vote from that different account. So let's do this. Connect and disconnect. Okay, let's refresh. Let's go connect to MetaMask. Now let's go here to this new account. Okay, next, connect. All right, all of this appears now. Let me go to, say, PHP and try to vote. And it says, you are not a member. Okay, so that actually worked. Let's become a member. Okay, confirm. Not too high. Okay, so the reason we're getting that is I need to reset this account as always. So let's go here and do that. Actually, it's saying not connected. Okay, I need to go to this account. There you go, connected. Let's go settings and reset account. Okay. Refresh. Become a member. All right, joined. Now again, we'd have to wait about 10 seconds for this data to propagate. Okay. And if I try to vote now, this should work. Okay, so let's try to vote. Confirm. Success. Wait our 10 seconds. Okay. And there you go. PHP is now updated. It's not always going to be 10 seconds, but that's what the maximum could be because that's when every new block is mined. Now you see everything updates, and there we go. We have our voting. All right. So with that said, I am going to wrap up the video here. This was a significant amount of work, but I wanted to show you how to create a fully functioning decentralized application with a better looking front end than what we had created before. Again, you can go and extend this project. You could spend, countless hours and days working on something like this, but this hopefully is a solid foundation to show you what you need to do, at least the starting points, to create, well, really a fully functioned decentralized app. With that said, I'm going to wrap it up here. I hope that you found this useful and got some value from this video, and I look forward to seeing you in another Blockchain Expert video.